Hi, this is Ren Huan from USTC presenting our work, PMail. Firstly, we provide a quick preview of our work. Most existing weakly supervised temporal action localization methods adopt the segment-based multiple instance learning framework, SML, where the predictions of segments are supervised by the labels of videos. Note that in this paper, the candidate proposal refers to a set of temporally contiguous segments. As shown in the left figure, during testing we need to score the proposals. However, SML framework scores the segments during training, which results in inconsistent scoring objectives and may lead to suboptimal results. Therefore, we propose a novel proposal-based multiple instance learning framework, PMail, as shown in the right figure, which directly classifies candidate proposals during both training and testing to maintain consistency. Next, we will provide a detailed introduction to our work. Given an input video, the task of temporal action localization aims to locate and recognize actions in the video. Under the fully supervised setting, it requires the start and end time points of the actions during training, which is a cumbersome annotation process that limits its practical application. Compared to fully supervised setting, under the weakly supervised setting, training only requires the category label of the video, which is easier to annotate. Most existing weakly supervised temporal action localization methods adopt the segment-based multiple instance learning framework, SML. Specifically, the video level classification scores can be derived by aggregating the class activation sequence, CAS, with the attention sequence, which are then supervised by the video level category label. During testing, candidate proposals are generated by thresholding the attention sequence, and then the corresponding segment level CAS is aggregated to score each proposal. However, this framework has two main drawbacks. Firstly, there is a discrepancy between the scoring objectives of the training and testing stages. During testing, candidate proposals need to be scored as a whole, while during training, the classifier is trained to score segments. These inconsistent scoring methods may lead to suboptimal results. Secondly, it is difficult to classify segments alone in many cases, as shown in the red box in the right figure. By watching a single running segment, it is difficult to distinguish whether it belongs to high jump, long jump, or triple jump. Only after observing the entire action and combining it with contextual information can the category be determined. In order to address the aforementioned issues, we propose a novel proposal-based multiple instance learning framework, PMail, as shown in Figure A. The overall training process is divided into two stages. In the first stage, an SML baseline model is trained, and the candidate proposals are generated by thresholding the attention sequence. Then, proposal features can be extracted with the surrounding contrastive feature extraction module. In the second stage, the candidate proposals are classified and aggregated into video-level classification scores, which are supervised by the video-level class labels. Since the proposals are directly classified in both training and testing stages, the proposed PMail framework can effectively solve the drawbacks of the SML framework. However, there are still some issues that need to be addressed within the PMail framework. Therefore, we further propose three key designs as shown in the subfigures below. Firstly, we propose a surrounding contrastive feature extraction module, SCFE, as shown in Figure B, which extends the left and right boundaries of the proposals, and then calculates the outer-inner contrastive features of the proposals. By taking surrounding contrastive information into consideration, those discriminative short proposals can be effectively suppressed. Secondly, we propose a proposal completeness evaluation module, PCE, as shown in Figure C. which treats high-confidence proposals as pseudo-instance, and then the completeness pseudo-label of each proposal can be acquired by calculating the intersection over union IOU with the pseudo-instance. Under the supervision of the completeness pseudo-label, low-quality proposals can be suppressed. Finally, we propose an instance-level rank consistency loss, IRC, as shown in Figure D, which constrains the normalized relative classification scores within each cluster to be consistent between RGB and flow modalities, achieving robust detection. Next, we demonstrate the effectiveness of our proposed method through experimental results. As you can see in the table, on the Thomas 14 and the ActivityNet datasets, our PML achieves the state-of-the-art performance. Compared with the previous SML framework, our PML can achieve superior performance with an average MAP improvement of about 3%. As shown in Figure A and B, our PML can solve some over-completeness and incompleteness cases in SML. And as shown in Figure C and D, our method can also handle some background interference and missed detection issues. In order to analyze the impact of each design, we conduct a series of ablation studies on the Thomas 14 dataset, and the results demonstrate the effectiveness of three proposed designs: SCFE module, PCE module, and IRC loss. Thanks for the attention.